Hey there, today we're going to learn how to rationalize the denominator of a fraction. And what that means is you have an example of a fraction on the screen here with a square root in the denominator, right? And the whole idea is that's an irrational number. We don't like irrational numbers in the denominator. We want to have a rational number there. We want to get rid of the square root to get a rational number in the denominator. And so that's the task, to get rid of that square root. So if you want to know how to do that, how to get rid of that square root, continue watching and we'll learn how to rationalize the denominator. Okay, so the main idea is not too crazy. Let's say I have a number like 1 over root 3. If I want to remove the square root of 3, what I can do is I can multiply this fraction by root 3 over root 3, right? I'm multiplying it by 1, but by doing it this way, I see that in the numerator, I'll just get a square root of 3, but in the denominator, the root 3 and the root 3 are sort of going to give us a root 3 squared. And that cancels out the square root sign, and so I'm just going to add a 3. So you can see what I've done is I've rationalized the denominator. I've gotten rid of the square root. I've kind of moved it up to the numerator. And we tend to prefer that. We prefer having the irrational numbers in the numerator and the denominator to be all rational. That's the idea, okay? So by multiplying by the square root of that number, you get rid of the square root sign. Now we're going to take this to the next level. We're going to consider problems where you have sort of a binomial in the denominator. So maybe one of these terms has a square root, maybe the other does, maybe it doesn't, but you need to get rid of this square root here. How do we do that? Well, we're going to be taking advantage of this special product rule right here. So if you multiply sort of the sum and difference of these two binomials, you're going to get the difference of two squares, a squared minus b squared. What we're going to do is we're going to multiply this fraction by x minus root 3 over x minus root 3. Okay, so let's see what happens. Now, the numerator is nothing special. We're just going to multiply these together. So we'll get an x cubed minus an x root 3. But the denominator, that's where the magic happens, right? So we can think of this as some kind of a plus b multiplied by an a minus b. So that's why we're able to follow this special product formula here. We'll get some a squared minus b squared. So translating that into these terms, that means we'll get an x squared minus a root 3 squared, just like that. But of course, root 3 squared is just 3. So what this actually equals is this numerator over x squared minus 3. And that's how we do it. We have gotten rid of the radical that was in the denominator. We have rationalized this number now. Now it's a rational number. It's just a minus 3. Okay, so that's the key. The key was multiplying the denominator by this specific term right here. We call this a conjugate radical. Okay, so this is what we have right over here. This is a conjugate radical. These two are sort of conjugates of each other, right? Because when you multiply them together, you get rid of that radical sign using this special product formula. And we can sort of generalize that formula here. So let's take a look at sort of the generalized form. Because we can have a coefficient. You could potentially have a coefficient in front of this radical sign there. But the whole idea is that if you could do some a plus b root c multiplied by an a minus a b root c, well then you get a squared minus b root c squared. And that gets rid of the radical sign. So we wind up finally with just this b squared times c, right? A squared minus b squared times c. That's how we can rationalize pretty much any binomial denominator here with a radical with a square root sign in it, right? So this is for square roots in the denominator when you have a binomial term. And that's exactly what we see right here. All right, let's try a few examples. So this first one, we want to multiply this fraction by the conjugate radical, right? So here that's going to be a 1 minus root 5 over a 1 minus root 5. So in the numerator, we just get a 1 minus root 5, but in the denominator, we're going to get a 1 minus 5, right? And so that actually, 1 minus 5, that's a negative 4, right? So we can think of this as a 1 minus root 5 over a negative 4. If you don't like having a negative sign here, you could think of this then as a root 5 minus 1 over 4. And that works just as well. Okay, so we can rationalize that denominator. Now it's just a 4. Let's try the next one. So here, the conjugate radical here would be a root x minus 1, right? So we'll do a root x minus 1 over a root x minus 1. And in the numerator, we're just going to get an x, a root x, a minus x. And in the denominator, now we get an x minus 1. Okay, pretty good. If you wanted to, you could write this x root x as an x to the 3 halves, right? We could use a fractional exponent there if we wanted to. But it's not necessary. Either way, you have successfully rationalized that denominator, gotten rid of the square root of x. And maybe let's try just these 2 more. So for this first one here, again, we have to multiply by the conjugate. Okay, so the conjugate will be this 2 root x plus root y. And we'll have the same thing here in the denominator. So in the numerator, we just wind up with, looks like a 10 root x plus a 5 root y. And now in the denominator, so here this will get a 2 root x quantity squared. So that winds up being a 4x minus a root y squared, which is just a y. Just like that. Okay, so this is what we have here. That's going to be the rationalized version here where we've rationalized the denominator. Let's look at the last one. Okay, the very last one here, we want to multiply by the conjugate, and the conjugate will be this root x plus 4 plus root x, right? And so that's going to be in the numerator and the denominator. So in the numerator, well, I'll just write this as 4 times, I guess, all of this. And now in the denominator, we'll get an x plus 4, a root x plus 4 squared, which is just going to be an x plus 4 minus, oh, sorry, I messed up here. This should be, the conjugate should be a minus, shouldn't it, right? Minus a root x squared, which is just going to be an x, right? So that's what we have over here. We can actually simplify this a little bit. If you notice, this x minus this x, that's going to cancel out. So we'll just get this, this numerator over 4, right? That's all we're going to get here. That's all that's left over. So that 4 is going to cancel out. And finally, we're just left with this root x plus 4 minus a root x. Not too bad. We've successfully rationalized that denominator, and it's disappeared completely. So it's gone altogether, and we've successfully simplified this fractional expression right here. Okay, so hopefully that helped you understand how we can rationalize the denominators here. We're specifically looking at denominators with a square root in the term, and they are binomials, right? You could use the same technique to rationalize the numerators, but that's just a lot less common. We typically don't like irrational numbers in the denominators. All right, so come back next time and we'll do a whole bunch of practice problems over this entire unit here, talking about rational expressions and fractions. I'll see you there.